What's up, guys? In the previous video lecture, I told you how the position and the velocity varies in simple harmonic motion with time. Okay, so we find out the position and the velocity as a function of time, and I told you that the position varies as a sine omega t plus phi naught, and the velocity varies as a omega cos omega t plus phi naught. Okay, let's delve a little further. Suppose I want to write this equation for a spring block system. So this is a spring block system. Mass m, k, spring constant k. Okay, and at t is equal to 0, at t is equal to 0, the position was at x equal to 0, and the block was moving, let us say, in the positive x direction. So velocity will be positive. So this is the initial condition given to us. Okay, obviously the block has to be somewhere at t is equal to 0, and that is required to find the function, the time varying function of position and velocity. So let us come back to our equation and write the position functions and the velocity function. Okay, so it is given that at t is equal to 0, x is 0. So let's first come to the position. At t is equal to 0, position is 0. So x0 is equal to 0 is equal to a sine 0 plus phi naught. So what I get, 0 is equal to a sine phi naught. From this equation I get that phi naught can be either 0 or 2 pi or 4 pi. I missed pi's. 3 pi, 5 pi, and so on and so forth. So we are still not clear whether phi naught will be 0 or it will be pi or 2 pi, 3 pi. Okay, we don't know. So how to find out what will be the value of phi naught? How to know what is the value of phi naught? So the other information that has been provided to us is that at t is equal to 0, the mass is moving in the positive x direction. So the velocity is positive. At t is equal to 0, the velocity is positive. So let us come to the velocity function. Vt is equal to a omega cos omega t plus phi naught. At t is equal to 0, velocity will be a omega cos phi naught. This has been put to 0. Okay, so a omega cos phi naught, this is the velocity at t is equal to 0, and we know that at t is equal to 0, the velocity is positive, so this has to be positive. A omega is a positive number, so we have that cos phi naught is positive. Okay, now what were the values of phi naught that we have? Phi naught is equal to 0, or it can be pi or 2 pi or 3 pi and so on and so forth. Okay, if I put phi naught as 0, I will get cos 0, and cos 0 is nothing but 1, and 1 is a positive number. Okay, so 0 satisfy the condition. If I put phi naught as pi, then I will get cos pi, which is equal to minus 1, and minus 1 is less than 0. So this does not satisfy the condition. So the value that satisfy the condition is 0. 2 pi will also satisfy, 4 pi will also satisfy, but 2 pi is nothing but the next shape of the cos wave. So it is basically time after one time period. Okay, which it's basically repeating the function. So we will not put 2 pi or 4 pi, we'll stick with 0. So we have found the value of phi naught for the above spring block system, where the mass is at x is equal to 0, at t is equal to 0, and the velocity is in the positive x direction. For such a spring block system, phi naught is 0. So the final function is xt is equal to a sine omega t, and vt is equal to a cos omega t. Okay, so we have derived the position and velocity for such a spring block system. If I ask you, how will you find the variation of potential energy? Variation of potential energy with time. How will you calculate? It's very simple. If you remember, potential energy in a spring block system is nothing but half k x square. So potential energy as a function of time t will be nothing but half k, which is constant, and variation of position as a function of time t whole square. Okay, so this will be half k, position as a function of time t we just derived, a sine omega t whole square. So this will be half k a square sine square omega t. This is the variation of position potential energy with time. Okay, what is the variation of kinetic energy with time? This is also very easy. Kinetic energy as a function of time t will be half m vt whole square. So half m a omega cos omega t whole square. So this will be half m a square omega square cos square omega t. This is the variation of kinetic energy. Okay, so you can also find the total energy. Just take it as an exercise. Prove that kinetic energy plus potential energy is constant. So use the above two expression, and you will also be required this expression omega is equal to under root k by m, using plus this one thing. Then kinetic energy is a function of time, potential energy is a function of time. Use it and prove that kinetic energy plus potential energy is constant. Okay, so this is it. So this is the variation of kinetic energy, potential energy, velocity, and position as a function of time. I've already told you their variation as a function of position. So we'll meet in the next video lecture with some new topic. Stay tuned and thanks for watching.